welcome to the second part of the scientific method lesson. We're going to use the same learning intention and success criteria as we did last time. And let's review what we did last time. We talked about the problem or purpose of an investigation, talked about how to research the investigation. We talked about making if-then statements for an investigation, which is called the hypothesis. And then we talked about conducting experiments, including using constants and controls, and knowing what your independent and dependent variables are. Remember, the independent variable is the one that I determine, or you as the experimenter. The dependent variable is the one that you're going to measure, or we also call it the responding variable. Today we're going to talk about some other parts of the scientific method. Once you finish an experiment, you're going to have numbers or data that you're going to need to analyze, and that's called your analysis. You're going to use that data, graphs, tables, anything that you've collected to make conclusions, and those conclusions will either support or not support your hypothesis. Once you've done an experiment, you have to share your results. In class, that'll be like a lab report, but real scientists report their information to scientific journals. Depending on what you're researching, there are specific journals that will report that information. Some scientific journals include Scientific American, the journal called Science, the National Academy of Sciences, and there's several hundreds of others. One of the things they don't want to report in their journals is anything that might be biased. Bias is bad. Bias is when someone tries to skew the results of an experiment to what they thought it should be. For instance, if you wanted to make sure that your kind of popcorn was selected for the whole school, and Mr. Baker asked you to do an experiment to determine what kind of popcorn would be the best for us to sell at the school, and you said, oh, I like Orville Redenbacher, and your classmate picked Jiffy Pop. If you skewed the results so that Orville Redenbacher always seemed to come out best whenever you popped it in your experiment, that would be bias. Now, how do you make sure that someone isn't biased? And how do the journals make sure that the information that they're reporting is not biased? Well, they make sure that they look at the records that were kept for the experiment. So you keep accurate records. What else can you do? Well, you make sure you use measurable data. It's not just an opinion that you're using, it's actual data. And the last thing is you make sure you repeat your experiment over and over again to make sure that it's not just an accident that it came out the way it did. That you've got lots of data that says this is how it's going to come out every time, or most every time. Sometimes you'll take an average, sometimes you'll use a mathematical equation, but the analysis and the conclusion are supported. If they're supported by repeated experiments, you've got a much more valid experiment and a valid investigation. Well, if you have any questions, please let me know. Ask questions and you'll get answers. The next step for us is to take a formative assessment and then a quiz on the scientific method. Good luck.